everyone. We are, I think, your last presentation for the day, and we are super excited to be here. And we just kind of wanted to show some secrets and sandbox fun on how to deal with multiple cloud backends, multiple Kubernetes clusters, and have Pulumi help you with that. So first of all, introductions, who we are. My name is Guinevere. I'm a software engineer at Plumi, and I work on the team that basically provides the plugins for the Plumi engine to interact with the cloud backends. So we are dealing with what we refer to as Plumi providers, and you can check out our work on the Plumi registry. And I'm excited to be here with my co-presenter, who will introduce himself.
Thanks, Gwen. Yeah, I'm Aaron Friel. I'm a staff engineer on the platform team. I work on the Plumi deployment engine, the code generation functionality, and most recently on the Yaml language support.
I know we're going to see some stuff that I haven't seen. It's pretty exciting. Let me move this forward. All right. So what we are going to do today, actually,
let me tell you. Yeah. Sorry, let me tell you a little bit about
brief overview.
Why multi-cloud? What are we doing today? We are going to be using Plumi, our automation API, and some of our abstractions around deploying collections of resources to provide a uniform sort of surface to deploy a Kubernetes application across multiple clouds. So we're going to be using something called a component resource. We're going to be writing that in TypeScript, and Gwen is going to show you that. We're going to be using the automation API. We're going to use TypeScript again for that. And then we're going to deploy a Kubernetes application in YAML. So you're going to see how you can use multiple languages, multiple clouds. And I will say what we're demoing today, it's a very simple Nginx web application. In order to actually go multi-cloud, you're going to need some of the presentations that we had earlier today. You know, if you need your storage, your networking, your TLS configuration, your infrastructure monitoring, like all of those talks earlier today, we're agnostic to, all of those tools. And we think that our infrastructure as code platform provides a great tool for deploying all of those systems onto your clusters.
Yes. In the ideal world that we're hopefully getting really close to, you should be able to use all those tools with Plumi to make sure that you have everything you need for true multi-cloud, whatever that means to you. So first, what we're going to do, there's going to be two parts to this demo. And we'll give you all a link to the example code repository as well. So first, we're going to create what we call a custom resource. A custom Plumi resource is basically an abstraction of a regular Plumi resource. But we basically, in the example that we're going to do is like, let's say that you are dealing with multiple customers and they all have, different deals with different cloud providers, and you just want to provide your service to them and provision their infrastructure, but they're telling you, well, we have to work with different clouds. So in our example, we're going to use some of the less well-known cloud providers. Nonetheless, not less awesome. We're going to use Sivo, Linode, and because I always like to check my things locally, we're going to also bring up a Kubernetes and Docker cluster, all of this using Plumi. Then Aaron is going to show you how to hook up our custom resource to the Plumi Automation API.
Yeah, exactly. So the automation API is a pretty bare bones wrapper around our Plumi deployment engine. It provides all the same functionality our CLI does: up, destroy, preview. However, you can programmatically interact with it in 4 of our supported languages. That's our .NET languages, mostly C#, TypeScript and Node, Go, and of course Python. So regardless of what sort of language you're using or what web framework you want to deploy it in, you can automate and deploy infrastructure, say even on just a web request. A very simple web server can automatically deploy your application. We find that our customers really like this for multi-tenant applications, deploy an entire stack just for maybe one of your customers or maybe for your largest customers, provide that isolation.
Yeah. So this is sort of touching on like why would you want this, who this is for. We already touched on this. with what we are going to show you, you will see that it is possible to abstract away a lot of the decisions that different teams have to make in order to bring an application all the way up from the infrastructure to, to the customer or to final production. And you'll be able to have nice segments of areas of concern, and basically abstract away a lot of decisions that you don't want to make more than once, because really, who wants to sit there and figure out the individual details of how a cloud provider works? I mean, it's my job, so I like doing that, but it should not be your job if you don't want to. So, because the both of us are engineers, we don't have any fancy graphs or, we just decided to head into demo time. So I'm gonna stop the slides, and share my editor. Nope, that did not work. Here we go. Let me give you a short minute, and here we are again. And I need to make this much, much bigger. There we are. So basically, let's say that I want to bring up Kubernetes clusters with Pulumi. So my first task is bring up a Civo cluster. In order for me to bring up a Civo cluster, I have some code here. I need to bring up a firewall first. I need to know certain things about the region and the firewall network rules. And then I'm allowed to bring up a cluster. And these are all some details. You'll see that these are very, very provider-specific details. But I can still use Plumi and TypeScript. You will see on my left here that this is an index.ts. I have some imports on the top. I have imported Pulumi. I have imported the different providers, Civo, Linode, and a kind provider that I'm going to talk about a little bit more in depth in a minute. So right here, let's swap away the Civo cluster. So the next thing I want to do is, okay, what is the same or the equivalent that I need to bring up a Linode cluster? All right, so here we are. It looks a little different. Still same idea. I use Pulumi to bring up a new cluster. It needs different args. And then this last one, I was actually looking. So the Linode and the Civo packages you will find on the official Plumi package registry. This particular provider for Kubernetes and Docker, also known as Kind, is actually a community provider. And if I am not going to make a horrible mistake, I will actually be able to show you where that is, or maybe I minimized it. All right, let's go back here. I have Plumi Kind. I will find that for you later. But basically what I found is a community package that was provided by somebody who decided Plumi was cool and decided to create a provider for Kind. And I found it on GitHub and downloaded it and compiled it locally. So the reason I mention this is because ideally we would want all of our community members to feel empowered and enabled to create these providers. And make sure they work in all of our supported languages, and then publish them to the Plumi registry. We have a pathway to. Oh, thank you, Aaron. That's the one. You'll see them. You'll see the link in the comments. So we want people to go ahead and publish their providers on the Plumi registry. Catch some good interactions. We would love to help with that. Moving along. So now I have a file where I declare 3 different Kubernetes clusters. And I can already see that whomever is going to bring up the clusters here is going to have to make decisions. How many nodes? Which Kubernetes version? How are we naming these? What does a kind cluster do anyway? Why do we need multiple nodes? All of this stuff. So I am going to cheat and scroll back up here. And actually, no, I'm going to go down. So basically, what Plumi component resources allow us to do is to create a wrapper around all of these clusters and call that something new. And that is exactly what we're doing here. We're going to export a new kind of Kubernetes cluster, and we called it Shiny Cluster because both Aaron and I like shiny things. And we are extending a Pulumi component resource, which just becomes part of regular Pulumi. And here you will see that it takes a name, it takes some specific arguments, and you can see that they support 3 different kinds of clouds. You can extend that to whichever cloud you want. We also have a node port arg, which will become important once we deploy our application later to our kind cluster. Then we are registering a Pulumi resource name called Shiny Cluster that allows the Pulumi engine to recognize this as a unique resource. And we are registering the outputs down below. As you will see. This particular thing is just a little implementation detail that we need to generate a random suffix for one of our providers right here, Linode. So now what is left to do is we need to implement the different providers. So with a few tweaks, what I have done is added all of these clusters that I defined, that I showed you first. I defined them as part of a switch statement so that I can just give my Shiny cluster a cloud as a name, Linode, Civo, kind, and have Shiny cluster bring up the correct cluster in the correct cloud. And at the very end, export the name of the cluster and the kubeconfig as an output. And right here, I'm registering both of those things as a Pulumi output. And now, if I wanted to continue manually, I can go ahead and run Pulumi up, generate a new Pulumi config, which will hold my it will hold the configurations for the backends that I want. And then I can bring up a new cluster right here. The args are reading from the Pulumi config. I could also just hard code the args, and then I could manually run Pulumi up from my terminal. Enter Automation API, which is where Aaron will show you how to consume these outputs and leverage the Automation API so you don't have to sit there and run Pulumi up. Let me stop share. Over to you.
Thank you, Gwen. Yeah, I'm just going to share my VS Code window here momentarily. So what I've done is I've taken the Shiny Cluster application Plumi program that Gwen has authored. I've placed it in a subdirectory of just another Node.js project. So this is just a simple command line application to illustrate that you can really instrument the Plumi API from any environment, web server, CLI. You can build your own custom wrappers around it. In this command line application, I've got just an interface defined for what do I care about from those outputs of that cluster. I've got a little helper utility for spinning up that cluster that will use that. And then in my main function, I've got a list of clusters that I want to deploy. For the Kubernetes and Docker cluster, I want to pass through a node port so that I can access that application locally. Oh yeah, certainly I can increase the font size. Does that look better for you? And then, I'm also using some Node.js async functionality here. So this promise.allSettled, more or less, it's just a loop over all of the promises that I'm going to create, async functions. For each of these clusters, I'm going to do a few things in sequence, but I want really to be able to deploy these in parallel. I don't want to have to deploy one cluster, wait for that cluster, deploy the second cluster, and so on. I've got a few helper functions here. I've got some output formatting. You're going to see some nice formatting in a moment. I've got this function called run Plumi project, which is that sort of, I said earlier, the Plumi Automation API, it's fairly bare bones. This is just a helper function to automate some of the plugging in config, running a couple operations, and then of course getting that pretty output that you're going to see in a moment. So we're going to spin up this Shiny cluster. we're going to make sure that succeeded. We actually have a cluster. So if we don't, we're going to bail out. And then we're going to run a second Plumi project. And we're going to plumb into the inputs, the config of this, the second project, this Shiny app, the kube config from the first. So that way, regardless of what cluster we deployed in that first project, whether it was Civo, Ninode, or Kind, we're going to take that kube config, we're going to plumb it into our Shiny app, and we're going to deploy a Kubernetes application onto that cluster. So with this, what I'm going to first show is just what the CLI looks like with a Kind local cluster here already deployed. So I'm just going to use TS node, which will run that index.ts directly. We got this nice output here. So cluster kind local, we're spinning up the stack, viewing this live. In this case, this was a pre-baked cluster. We're going to deploy an additional cluster in a moment here. And then I have a node port of 32,001. What I'm going to do now here is I've got a couple clusters I've already written here for Civo and Linode. I wanted to spare folks on the stream. You know, sometimes spinning up a whole Kubernetes cluster on a remote environment does take a few minutes. So I've got some clusters already deployed, but I'm going to deploy a second Kind cluster as well. So let's just get a name for this, Mighty Bulldog. So let's do name Mighty Bulldog, Cloud, Kind, node port. Let's give this 30,002. And so what we're going to do here is next time I run this, we're going to spin up a new Kind cluster. That's going to be this Mighty Bulldog. We're going to actually reuse our existing deployed Civo and Linode clusters. And then we're going to deploy the Kubernetes application to all three of those. So I'm going to let this run for a second. It's going to fill up the terminal with the output of all of these deploying simultaneously. I'm going to minimize that a little bit because it is going to be a little bit noisy down there, and spend a second talking about what are we deploying to this cluster. For our Shiny app, we are using our YAML language runtime support. So we know that engineers of all stripes have preferred languages and runtimes and tooling. We really wanted to, with the most recent launch of the YAML language support, our ops and infra folks who are most familiar and comfortable with YAML. And this is our YAML language. So we've got a configuration here. We've got a couple inputs that we basically are providing. So this is the stack config. Each stack is going to have its own kube config, its own node port, and we can deploy multiple stacks in the same project. So we have a kube config, a service node port, which is going to be optional. It has a default of 0, service type. For our clouds, our remote clouds, we're going to use load balancers. And then for our Kind cluster, we're going to use a node port. And then we have a Nginx Docker image that we're going to deploy as well. We have some variables we can declare and reuse. We're going to declare a Kubernetes provider here. This is then it's going to take that kube config, and we're going to then provide that provider to all of our Kubernetes resources we're going to deploy. You're going to see the syntax here is extremely similar, almost verbatim, copy and paste what you could see if you go to Kubernetes docs. So the application, it's a V1 deployment. We've got that Shiny namespace name. So we're actually relying on Kubernetes and Pulumi's auto naming here. So we're going to get a Shiny, some hex string suffix automatically, make sure that we're not interfering with any existing deployments. And then a service, which again, we've plumbed through what type and node port to use. And then for outputs, we're going to output the service status and the node port if it's there as well. So if I expand my terminal here, it looks like we've actually succeeded in everything, deploying, fantastic. I realize scrolling can be a little distracting here. I do see that the Mighty Bulldog output, it's available on port 32,002. So let me just make sure that is working. Great, made with love in Plumi. I'm actually just going to run this script again so you can see how quickly that we can actually use the automation API here. So now you're going to see essentially all 4 clusters. They're going to refresh. They're going to check to make sure that they're up to date. And then all their apps are going to redeploy. I'm just doing this again because that'll push all of those outputs, which you'll see some URLs and some IP addresses shortly to the end here. And let's see here. Let me make sure I've got this correct. Did I not output the outputs? App or interesting. So I apparently don't have outputs. Love to see demos go a little awry. So I've got my kind local and my kangaroo, and then they exit. Let's go ahead and remove this and insist that this is there. Let me run this again. So now we're refreshing our 2 remote clusters. And very curious, I am not seeing in our loop my right kangaroo and top ghost. Who doesn't love debugging things live? Okay, we are just stuck on the refreshing. Let's just go into, I can use regular Plumi commands to debug this. So I can go into the Shiny cluster folder, Plumi stack, Plumi select top ghost, Plumi preview. Let's see. I have not exported my Linode and Civo tokens to my CLI. I'm going to unshare my screen one moment here. I think I created a new terminal, and that would definitely be a blocker. 1 second here. So for this demo, I was relying on ambient authentication, which is not something I recommend that our users do. We do support with our state and config encrypting secrets, which you'll see momentarily. But let me make sure I have our API keys entered here.
Yeah, you can definitely add secrets to the config. We just figured out it would be a little bit like, yeah, very specific to your use case and to your cloud, and a little both boring and dangerous to bring.
Yeah.
So thank you for enjoying our faces in the meantime.
Okay, let me reshare my screen. I think this will be a little more exciting now. Let me share. Okay, so we also got a little bit of live debugging of what this looks like. So now I've exported, I've cleared my window, so you can't get our tokens. But if I do a Plumi preview, I do see that Top Ghost now it's returning successfully. So it is just a plain Plumi application that I'm running using the Automation API. Now, if I do a index.ts, we should see, there we go. We're going to see this refresh. We're going to see it deploy. These clusters are already live, but the Kubernetes applications are not. So we're going to see momentarily the app is going to spin up. We're seeing that output interleaving. We're deploying to both clusters at the same time. And hopefully our load balancers are warmed up as well, so that we're going to get a pretty quick IP address out from both of these. Fantastic. All right, so we've got an IP here. Let's just do a quick curl to that. Made with love and Plumi. Curl to our second cluster. We're waiting a second. I'm not going to knock it if one of our other cloud services is sometimes we have to wait for load balancers resolve all those other things. There we go. Actually, it just took another second.
Do you suppose we can like paste that link into the chat and have people see it?
Sure.
Because I think it's public. Yeah.
Yeah. I think that the DNS is always it's DNS, right? So the IP addresses are going to work immediately. The DNS names, I'm not going to bother copying and pasting those. Those are going to go away in a short time anyhow.
Yeah. All right.
Thank you. Back to you, Quinn. Sorry about that live debugging.
Let me grab the screen. Yes. All right. Thank you all for hanging along with our demo. I have one more thing that. So in summary, let's just wrap this up. We chose some cloud providers. We created a Shiny cluster custom resource that is able to talk to all these clouds with a few generic inputs. We showed how to make this resource flexible and provide exactly the outputs that the automation API needs to run this for you. And then we programmatically deployed an app, and we first deployed infrastructure using the automation API, and then we also deployed an app. And all of these things were super shiny. So let's say let's talk about this a little bit. Is this true multi-cloud? Aaron brought this up earlier. Really, I remember people being like, "Oh, multi-cloud, what a buzzword." And I mean, personally, I think we don't have to make that decision for you. We just provide you with the tools so that you can decide what multi-cloud means to you. So yeah, thank you for having us. This was super fun. And I think we have time for some questions, but I might be wrong. Nope. Yes, that was a yes.
Yeah, thank you. That was really good and really good demo debugging. I felt the adrenaline. It was riveting. Yeah, so I'll just highlight, I mean, we have a bunch of questions, so I could just highlight some, and you already ran through like a little bit of them, but I just want to highlight them again so you have just the opportunity to do that. And,
Refik, I believe I have that. I hope I have that right. Asked, we have some Python examples. We didn't write one for this. We actually considered writing the CLI in Python, but we already had some things written in TypeScript. But I do want to show off a little bit what we can do with the YAML language support. So if we could pop up my screen again, center my VS Code window. So I've got this YAML application here, and infrastructure engineers, they might prefer to write in YAML, but maybe we want to pass this off to an application team where they're more proficient in Python, or they want to add some things that we don't support in YAML, loops and things like that. So I'm just going to go into my Shiny app directory. I think I've already got in my history Plumi convert, which is this magic command that we've implemented. We can convert our YAML to Python, TypeScript, Go, Java, even our latest general purpose language. And we'll go and find out what dependencies you need. We'll install that. We'll actually set up a virtual environment. And what you end up with is the same application, now runtime Python. And in the main.py, you can see that this is just Python now. We've turned that YAML program into a Python program. We've tried to implement things like default, so you can see like we're doing default setting, setting all the properties here.
Nice, that's pretty cool.
Yeah.
And go ahead.
Yeah, no, I just like that you can just separate out your concerns and decide on a language, and it will just work. So you're not really forced to, learn TypeScript if you don't want to.
Yeah, that's very cool. And also I see that you all have a YouTube channel that has a lot of these demos and workshops, so people can go there. And then here's another question from Conrad. Are there instructions for creating Pulumi runtimes?
Yeah, and I saw, Conrad, you also asked if there was a ability to use Rust, everyone's favorite new language. It's actually one of my favorites as well. I would say, Conrad, get in touch. I'm certainly interested. We need to figure out, how interested other folks are in using this. It's a pretty new language. It's a pretty new language for infrastructure folks, especially. It's a challenging language to use, but there might be some things we can do with that.
And then people want to know how to get in touch with you.
We do have a Plumi community Slack. So that's plumi-community.slack.com. So folks can ask us questions there. And of course, all of everything you saw today is open source. So you can reach us via GitHub issues. You can find our repositories, let us know how we're doing. And of course, I think you can find Gwyn and I on things like Twitter and other things as well.
Maybe I
should just speak for myself there.
You can reach me on Twitter. It's here's the Slack link. It's actually slack.plumi.com. Maybe that's another alias, but actually just
cool. So that's popped into the chat. We can put it up. Oh, you got it. Okay,
that's the one. And then one of our developer advocates runs Raw Code Academy on Discord. That has a Plumi channel. I actually don't know how to get it. It just lives on my phone, where it's been for long enough that I don't remember. But it's active.
Googling, right?
It's active. You can ask to join. Lots of people sharing, lots of people learning. There's community rules, as with our community Slack as well. Then, Conrad, you asked if Plumi is used to programmatically create and deploy to Kubernetes clusters. Absolutely, yes. In fact, our big umbrella Kubernetes provider is one of our top tier packages. You will find it on the registry. It is Plumi official. It is very active on GitHub. It gets a lot of personal attention from my team. People in my team, there's already pre-baked components that you can probably find on the registry that should help you out. I just saw a few whiz by yesterday, and there's a difference, of course, between creating the clusters, which is what I showed you today, because I used to be more on the ops side of things. And then the big Plumi provider, Kubernetes provider, is really more for the deploying side. So it assumes that you have a cluster, and then you can use Plumi to create all of your Kubernetes resources targeting your cluster. But you can do both, as you saw today.
And then there's this other question.
Can you convert Terraform code to Plumi in a especially Pythonic style? So yeah, we do have a cool tool called TF2 Pulumi. We try to build a few different tools to help folks convert their infrastructure as code from Azure Resource Manager, Terraform. I think we might have one or two more. I think we have a Kubernetes to Plumi as well. What we find, though, is we're targeting those other tools in their languages. They sometimes will innovate faster than we can keep up to date. So if you do find any issues, of course, please reach out, file an issue. We do consider it a bug if we fail to convert your program to Plumi.
Yeah, we do have migration guides that are available on the Plumi website, plumi.com.
Mm-hmm.
If you search for it, you will find the migration guides.
Yeah. And just sort of, I guess, speaking from an operational perspective here is, converting your existing running applications from one infrastructure as code tool to another. Obviously, we would love it if you would convert to Plumi, but we find that our customers are very successful starting greenfield applications, because they can then take advantage of refactoring their code in a more idiomatic style, right? They don't have to conform specifically to how their Terraform was structured or how their other infrastructure as code tool was declaring everything.
Plus, you can always use Plumi like side by side with what you already have. So
excellent. I think
And
some
is that all the
great feedback.
questions?
So we'll thank you, Aaron. Thank you, Guinevere.